James Webb Space Telescope spotted a large object, the object changing its trajectory in an unnatural manner.
The James Webb Space Telescope just recorded something scientists were not prepared to see.
There's a mysterious interstellar object hurtling towards our solar system, exciting scientists across the globe.
3I Atlas is behaving in ways no natural body should. Its movement, its signals, and its structure do not match known physics.
The plume of gas around it is mostly carbon dioxide, 95% by mass, based on the Webb telescope data.
Multiple observatories confirm the data. The concern is no longer whether this object is unusual. The concern is whether something is actively controlling it. When the sun moved, everything changed. Most people first heard the name 3I Atlas when ground-based telescopes detected a faint object entering the solar system.
In addition to ground-based studies, NASA's space telescopes like Hubble, Webb, and SphereX.
At the time, it looked like a harmless interstellar visitor similar to earlier discoveries. Nothing about the early readings suggested a major event. Astronomers simply prepared to track it as it approached the inner system. The James Webb Space Telescope became central to this plan. Webb operates above Earth and uses advanced instruments that can examine distant objects with exceptional detail. Teams scheduled a full set of observations for the moment when 3I Atlas moved far enough from the sun's glare to be seen clearly. When that moment arrived, the data did not behave as expected. As soon as the light interference eased, Webb detected a sudden brightness spike. The increase was far beyond anything predicted for a natural body of this type. The object's brightness rose more than 400%. The rise did not follow the fast and uneven changes seen in comets that heat up near the sun. Instead, the increase was smooth and controlled. Analysts studying the light curve said it showed a level of stability they would never associate with a comet. According to several early reports, the rise looked too organized to come from natural heating. While teams tried to understand the spike, Webb recorded another unexpected feature. Its instruments showed a reflective pattern moving across the surface of 3I Atlas. The shift did not appear random. It moved in a steady progression, as if something under the surface adjusted its alignment. Processing teams who reviewed the early frames said the glow behaved like a controlled surface, rather than drifting dust. Some specialists suggested that it looked like engineered reflectivity.
Whether the object is of that size or maybe much smaller and surrounded by a cloud of dust.
They labeled the idea speculative since it needed more evidence, but the observation remained difficult to explain with familiar models. As the images sharpened, astronomers began to notice structure beneath the glare. The refined data revealed hexagonal segments arranged in a clean grid. This pattern did not match natural formations. According to internal notes, several teams checked their processing steps repeatedly to rule out error. The results stayed the same. The segments appeared too perfect and too consistent to be accidental. The finding spread through scientific channels and was described as one of the most unusual surface features ever recorded on an interstellar object. Before the teams could reach agreement on the geometry, Webb detected a new signal. A repeating ultraviolet pulse appeared at exact 247-second intervals. The timing did not drift. It remained precise through every observation. Multiple instruments confirmed the same interval. Some researchers proposed that the pulse might represent an internal process, or some form of controlled activity. Others urged caution and stated that the idea remained unverified. Even with restraint, the pulse added another element that did not fit the behavior of a comet. Together, the brightness spike, the controlled reflective shifts, the hexagonal grid, and the exact ultraviolet pulse formed a picture that no known model could explain. According to teams working on the data, 3I Atlas no longer showed the behavior of a natural object made of rock and ice. That conclusion forced every group to move beyond single anomalies and test whether all the unusual signals formed a single, coherent pattern. The rules of comets no longer applied. Once the early data from 3I Atlas spread through research groups, many scientists expected the object to settle into familiar comet behavior.
From images, we also saw that this object is active, which means that around the nucleus there is some coma, which is an indication that this object is in fact a comet.
Most comets release jets of gas and dust in random bursts. They heat up unevenly. Their brightness rises and falls in ways that no one can fully predict. This object refused to follow any of these patterns. According to several early analyses, nothing about its behavior matched the natural habits of a comet moving through the inner solar system. The first major concern appeared when teams studied its path. A natural object follows a curve set by gravity, sunlight, and its own drifting jets. 3I Atlas did not follow that type of path. Its movement looked sharper and more controlled. Simulations that normally recreate the behavior of comets failed to match the way it turned. Some teams reported that the object bent its trajectory in ways that made no physical sense. The change was small but clear enough to trouble experienced researchers.
And if it's definitely technological, that may be a threat to Earth.
As more observatories joined the effort, a new problem became obvious. Every group recorded light curves that did not match one another. A light curve is simply a record of how bright an object becomes over time. For a comet, these curves usually follow the same general shape. In this case, the curves disagreed in extreme ways. Some showed 3I Atlas dimming quickly, as if something blocked its light. Others showed smooth brightening, as if the object wanted to reveal more of its surface. Specialists who compared the curves said the differences were too large to come from normal measurement error. Several individuals said privately that the dimming looked intentional on some nights and the brightening looked regulated on others. They stressed that these ideas were speculative, yet they could not ignore the pattern. The inconsistency grew with each new dataset. Every time a team tried to place the readings into known models, the models produced unexplained results. It was as if the object shifted its behavior between observations.
And then it will move on to the next star along its path, and if it has been doing that...
According to unverified reports, some astronomers asked whether the object was reacting to the act of being observed. This idea was not accepted widely, but it showed the level of confusion spreading through the community. Even experienced astronomers began to express concern. Many of them had spent their careers watching comets behave in chaotic and unpredictable ways. Yet they still described the motion of 3I Atlas as guided rather than random. They did not claim it was controlled, but they said it looked too deliberate for comfort. As uncertainty increased, attention turned to an approaching problem. 3I Atlas was moving toward a position where the sun would hide it completely. Observers knew that when it slipped behind the sun, there would be no data at all. Preparations were made for the blackout, but most scientists expected the interruption to be brief and uneventful. When the blackout began, no one expected that the silence itself would become the next clue. A blackout no telescope could penetrate. As 3I Atlas moved into a position where it sat too close to the sun from our point of view, telescopes began losing it one instrument at a time.
3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
Ground-based observatories reported that the object faded from view. Space-based instruments that depended on direct sight experienced the same problem. Within a short period, 3I Atlas disappeared from all routine monitoring. This loss of visibility had been predicted. What happened afterward had not been. Days passed with no new optical readings. Then a week became 2, then 3. The object became a blank space across publicly available instrument feeds. Teams that had been trading data and notes found themselves with nothing to share. Internal channels filled with short, urgent messages asking whether a signal had been missed or a pipeline had failed. Nobody could find an error that explained the silence. The complete lack of reflected light was unusual. Even very faint objects normally leave a small trace when the data is processed carefully. Teams expected at least a minimal signal from 3I Atlas. According to reports from several groups, no trace appeared. The object produced no measurable imprint in any of the optical ranges that were reviewed. Scientists widened the search. They began blind scans using radio telescopes and infrared sensors. Radio observatories swept the coordinates looking for any type of emission. Infrared arrays looked for heat that might remain detectable even near the sun. Every attempt produced empty results.
You will see no radio signal. The SETI community will continue to watch the sky.
Radio teams reported only background noise with no organized source. Infrared teams reported readings that matched normal background levels. According to internal briefings, each independent check confirmed the same outcome, which was the absence of any detectable signal. The missing signature triggered debate across the research community. Some researchers wondered whether the reflective surface seen earlier had collapsed or changed during the period behind the sun. Others suggested that the surface might have rotated or reorganized in a way that reduced reflection. These ideas were labeled as speculation, and all of them remained unverified. Another possibility was raised by groups familiar with limits in observing geometry. They argued that the blackout might be caused simply by the object's position in relation to the sun. They noted that even advanced instruments can lose track of certain behaviors when an object sits too close to sunlight. The blackout still set a record. Teams described it as the longest stretch without reliable readings from any interstellar object. That fact alone made the situation more serious. Scientists who had studied previous interstellar visitors said that gaps in information are always a problem.
NASA were to greenlight a mission. What are the measurements or data that you would need returned?
But in this case, the gap felt more severe. There was no fading signal to follow. There was nothing for analysts to work with. Concern grew across the community. Meetings focused on emergency planning rather than on analysis. Groups discussed how to coordinate instruments for the moment when the object moved far enough from the sun to be seen again. Researchers described worry and impatience. Some expressed fear in private notes about what might have happened out of sight. Others reported frustration at the limits of observation that left them unable to detect any change during a critical period. The absence of data became one of the most troubling parts of the entire event. Without readings, speculation increased and confidence decreased. According to several internal summaries, the blackout shifted the mood from curiosity to real concern. When 3I Atlas finally emerged again, the first numbers removed any belief that it had stayed the same. It returned brighter, colder, and more controlled. When 3I Atlas reappeared from behind the sun, the first readings from Webb stopped the room. The James Webb Space Telescope recorded a surface temperature that did not vary with time. For a comet or a fragment of rock and ice passing near the sun, this is impossible. Comets warm as they approach the sun and cool as they turn away. According to several instrument teams, the temperature of 3I Atlas remained steady within the instrument's limits. That detail alone forced scientists to revise basic assumptions. The object did more than hold its temperature. Its outer layer behaved like a regulated shell. Reflectivity changed in ways that suggested active control over heat and light, rather than passive absorption. Analysts who examined the polarization and spectral responses reported patterns consistent with a surface that could adjust its reflective properties. These assessments were described as provisional and speculative in internal notes, but the same trend appeared in independent pipelines. Brightness no longer jumped erratically. Instead, it rose and fell in smooth arcs tied to the object's rotation. The light curve looked deliberate, not noisy. Teams described the changes as predictable across multiple rotations. Those who had worked on spacecraft imaging pointed out that systems designed to manage light do exactly this. They emphasized that this comparison was speculative and required more data, but they also said the match was striking. As images improved, segmented patterns became visible beneath the reflective layer. Processed frames showed panels or plates shifting into alignment. Observers compared the motion to mechanical plates settling into place. That language appeared repeatedly in field notes and private channels. Everyone who saw the frames described a clarity that brought both fascination and a rising sense of alarm. Crucially, none of these changes showed signs of thermal stress. If the surface had been forced to reconfigure by heating or cracking, scientists expected to see fractures, dust plumes, or irregular degradation. According to reports from calibration teams, the surface remained intact and consistent. No fresh dust clouds, no collapse of features. The absence of damage strengthened the impression that whatever had moved on 3I Atlas did so with control. Some analysts used a working analogy to spacecraft hardware. They said the behavior resembled adjustable panels used on human craft to manage sunlight and heat. Those panels tilt and reorient to control exposure. Researchers labeled the analogy as speculative and highlighted the need for more measurements. Still, several groups flagged the similarity in written summaries sent to collaboration channels. Attempts to explain the reflectivity through natural processes faltered. Models that invoked dust vents or gas jets could reproduce certain brightness changes for short periods. They failed to account for the steady temperature, the consistent aligned segments, and the repeatable arcs tied to rotation. Natural jets are chaotic. They cannot produce long-term, regulated reflectivity across a surface.
Interstellar objects and decide, if it's a natural object for sure.
According to multiple teams, the combination of observations left fewer plausible natural explanations. With every new image, the object moved further from familiar categories. Shock and worry spread through the community as the evidence accumulated. Some researchers admitted fear in private notes. Others showed anger at the limits of existing models. The consensus in public summaries stayed cautious, labeling many points speculative and calling for continued verification. But the next observation destroyed the last remaining assumption that 3I Atlas was merely unusual. The tail that pointed toward the sun. The return of clear observations revealed a detail that unsettled every research team. 3I Atlas began releasing a single strong jet of gas from its surface. At first, this looked like normal comet behavior because comets often produce jets of gas when they heat up. That expectation collapsed quickly. Instead of trailing behind the object, the plume pointed directly toward the sun. Comet tails always point away from the sun because sunlight pushes the gas outward. This plume did the opposite. According to multiple reports, researchers checked their instruments repeatedly because no known natural force in the solar system could reverse that effect. Confirmation came from several independent observatories. Hubble recorded the same inward-pointing plume, KEK. a major research center in Japan, confirmed it. Several European observatories reported the same result from different viewing angles. Each team saw a thin line of material that held steady and aimed into the sunlight instead of away from it. The agreement across so many instruments removed the possibility of equipment error. The plume did not behave like natural gas. It stayed narrow and steady for long periods. Natural jets from comets scatter, wobble, and break into uneven clouds as the surface rotates. None of that appeared here. The plume maintained a concentrated form that did not match any known comet activity. Scientists tested every explanation familiar to them. Solar radiation could not push the plume inward. Rotation could not force the plume toward the sun.
A comet that shouldn't even exist has lost its tail, defied physics, and grown mysteriously brighter when it should have become dull.
Sublimation, which is the ordinary process where ice turns directly into gas, could not create such a focused stream that ignored the sunlight. According to several internal analyses, the alignment of the plume matched no natural mechanism. A more alarming pattern appeared when analysts studied the object's motion. Each time the plume strengthened, 3I Atlas changed its path slightly. The change was small but measurable.
So a strange voice from deep space, a mysterious object named the 3I Atlas, has just sent a signal aimed directly at planet Earth.
Analysts reported that the motion looked similar to controlled thrust seen in spacecraft. They stressed that this idea was speculative, but the changes in the object's path occurred at the same time as the plume bursts, which made the possibility difficult to dismiss. As sharper images arrived, propulsion specialists, who study how engines guide movement, raised further concerns. The pattern of movement looked closer to engine correction burns than to gas escaping naturally from a surface. These observations appeared in private notes and early drafts of reports. Writers marked them as unverified, but many teams acknowledged that the evidence pointed toward some form of guidance.
And it's only the third object ever confirmed to have come from interstellar space.
The reaction across the scientific community changed quickly. Until now, many believed 3I Atlas was unusual but still within the range of natural explanation. The inward-pointing plume and the controlled shifts in movement changed that view. If something can adjust its direction deliberately, then it can choose where to go next. Some researchers describe this stage as the moment 3I Atlas stopped being a harmless visitor and became a potential threat. Others expressed frustration at how far the data had moved beyond accepted models. Some teams said openly that the situation had entered unknown territory. According to several summaries shared inside the research networks, this stage marked a clear turning point. 3I Atlas no longer behaved like a fragment of ice and rock. It behaved like something built with purpose. Evidence from later analysis revealed that the very structure of 3I Atlas raised even more questions. The hollow interior and the engineered shell. The unusual gas stream and the small changes in 3I Atlas's movement forced scientists to expand their investigation. They turned to spectral analysis, which is a method that studies reflected light to identify the materials on an object's surface. The first results increased concern. Webb detected a nickel-iron alloy on the surface of 3I Atlas. Natural comets contain mixed metals with many impurities, but this alloy appeared unusually pure. According to several analysis teams, the reading suggested a level of refinement that natural processes do not normally produce. Researchers stressed that this finding needed careful verification before any firm conclusion. More unexpected results followed. The spectrum showed cyanide compounds built into the surface itself. In normal comet chemistry, cyanide appears as drifting gas that escapes when the comet warms. Here the compounds did not drift. They stayed fixed in the structure. Specialists in comet composition noted that this pattern did not match known natural behavior. Their statements were cautious and labeled as preliminary, but the difference from normal comet chemistry was clear. Scientists then examined how light behaved when it struck the object. Some wavelengths showed patterns that suggested open space behind the surface.
It turns out that the two directions of the wow signal and 3I Atlas are aligned.
This behavior can occur in hollow structures. Several teams recorded the same result and said it hinted at internal chambers rather than a solid interior. They emphasized that this idea was speculative because such patterns can have multiple causes, but the readings were consistent across multiple observations. Mass measurements added to the confusion.
The comet's path will take it past even more of our robotic explorers.
The object was far lighter than its size suggested. Analysts compared its volume with its estimated mass and found a mismatch that was too large to explain with mixtures of ice and rock. According to reports from gravitational modeling groups, the numbers supported the idea that the interior was mostly empty. This result created tension because it conflicted with standard expectations for interstellar objects. The earlier brightness pulses also took on new relevance. When compared with the hollow interior possibility, the pulses looked like light reflecting inside an open shell. The timing and movement of the pulses matched the idea of light bouncing through empty space. Some researchers said this suggested internal gaps large enough for light to travel through. They marked the idea as speculation, but it appeared frequently in internal discussions. Spectral data revealed still more details. Rare absorption lines indicated layered materials. These layers did not match the natural formation patterns found in comets. Analysts who reviewed the lines said the arrangement looked structured and organized. They described this as a possible sign of construction rather than natural layering, while stressing that confirmation was needed. During rotation, the spectral readings stayed unchanged. Natural surfaces shift slightly as they turn, but here the data remained consistent. According to several teams, this stability pointed to a controlled, uniform outer surface instead of a natural one. Piece by piece, the evidence formed a single picture. According to many researchers who reviewed the data, 3I Atlas no longer resembled debris. It showed signs of construction and intention. This view remained unverified in official notes, but it continued to gain support. But the most serious surprise came next. Webb detected something far beyond 3I Atlas. Another object was approaching from deep space. Webb detects a second object, and 3I Atlas sends the signal. After weeks of focused work on 3I Atlas, teams rechecked deep archive scans from the James Webb Space Telescope and found something that had been hiding at the edge of detection.
NASA-funded telescopes have their eyes on the sky all the time.
Webb recorded a faint mass far beyond Neptune on a trajectory that did not match any previously cataloged object. The signal was weak at first, a whisper in the data, but it was real. Analysts who reprocessed the images flagged it as unmistakable and concerning. The timing produced immediate alarm. The final ultraviolet pulses recorded from 3I Atlas before it departed aligned precisely with the incoming object's path. The pulses had once been treated as odd periodic noise. According to internal reports, cross-checks showed the pulses matched the distant body's approach, as if they encoded a set of coordinates. Several teams described the match as too close to be coincidence, though they framed that statement as provisional and subject to further verification. The newcomer itself behaved like nothing the community had seen. It showed no thermal signature when viewed in infrared bands. It avoided reflection in the wavelengths most telescopes use to find faint bodies.
Now, the world's most powerful telescopes are hunting for answers to a question that keeps astronomers awake at night.
Observers described it as cold and deliberately non-reflective. Some analysts suggested that the lack of thermal and reflective signals could indicate active measures to remain unseen rather than simple distance. Those interpretations were labeled speculative and unverified in formal notes, but they circulated widely in private channels. As the faint signature strengthened, the object adjusted its course in small, measurable ways. Trajectory updates showed subtle changes that coincided with the last pulses from 3I Atlas. According to several teams, the motion looked responsive. The pattern suggested that the departing object had sent a locator signal and that the distant body had reacted. The correlation moved quickly through collaboration lists and triggered urgent cross-checks at multiple observatories. Once that link formed, the narrative changed inside science groups. Researchers began to treat 3I Atlas as a forward probe rather than a lone visitor.
3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
Early internal summaries used guarded language but described the object as a scout that had mapped the system, transmitted information, and left. Those assessments remained speculative in public-facing documents, but the consensus inside collaboration networks hardened quickly. The implications were immediate and chilling. If 3I Atlas had been an active scout, then the incoming body could be part of a larger mission or fleet. The behavior shifted the conversation from anomaly hunting to threat assessment. Scientists who had been cautious about speculation now spoke openly about the need for broader coordination across agencies and nations. Fear and urgency rose in status updates and private messages. For many observers, the largest shock was not the alien nature of 3I Atlas itself. It was the arrival of something far larger that appeared to be responding to its signal. With the second object now approaching, the world is left to confront a future no observatory ever prepared for. If you enjoyed watching this video, kindly like and subscribe to this channel.